Hi, I am Shahid Reza. I am head of AI engineering Oracle. I am here to talk at the Developer Live about AI/ML for your enterprise. We are talking about a very specific things where you have a model. Now, what do you want to do? How do you go about in creating the model and deploying those machine learning model on autonomous databases? So let's dig and deep dive into this topic. This is our safe harbor statement. This is the outline of our presentation today. We are talking about machine learning models, so it's better we understand a little bit what does a model stand for. We are going to give a series of demo. The demo is about how do you deploy the model with Oracle Machine Learning, how do you do that with SQL, with Python, and then there is question of how can you put a native Python model over there using OML. Now there are certain set of users who are going to use this model but they don't understand how to use all of these codes. So for them AutoML UI is a boon in disguise, and that's where we will be using an AutoML UI and demo to help you understand how you can use that. There are chances that you will also be hitting upon some third-party solutions which requires such as TensorFlow, which will require things like ONNX based models. So you can use or do that. So we're going to see how we can deploy a third-party ONNX model to OML REST service. Finally, we're going to talk about a little bit of our experience and going to round up with few of the things which we have learned earlier and summarize and cap it. So let's understand what is a machine learning model. A machine learning model starts with the understanding of the business, but it goes from a data understanding to data preparation. In the data preparation, we understand that there are multiple ways we can classify our data. This classification of these data is called modeling of the data. In that modeling, you can do few things, as you can classify a cell, you can identify a transaction, whether it is a fraud or not. You can also find or predict or find the probability of a particular ad, whether he's going to click on that particular ad. Anomaly detection is another feature which can be provided with modern days machine learning models, by which you can almost tell whether things are going to be good or bad, or things are going to fail on a particular thing. There are further other things which you can do, like credit scoring, value of an house, and group to which the customer belongs to. These are all different kinds of models which can be done at the end of the day. There are other models as sentiment models, and then there are NER, and there are a few other things which can also be done. These evaluations can be done with the help of these models, but you need a way to deploy these particular models once you have created this model. Let's go a little bit deep into understanding what is a model consist of, so that we can actually break it down and see how we are going to deploy these particular models. So when you're writing a business model and understanding a business problem, the first thing you will hit upon is the fact that it is using a mathematical formulation. That mathematical formulations can be very simple, as a linear regression model, or a few things will be there, or it can be very advanced. And when you have advanced, then you will have multiple layers of artificial neural networks, and there could be a single layer network or multiple layers also over there, and these will be hidden layers. So you call CNN, RNN. There are a lot of other things which can also be used. Now we have to translate all of that into a mathematical formulation, take that input, put it into a model file, and then store that particular model file in a model object and their metadata. And this is where we will have to take it and store that particular model and then use it for scoring our FAR data. That's what we are going to learn today, how we can take a particular model, store it with us as a model, then going to deploy that particular model, and then use it with scoring it with the help of external applications. Let's start with a very simple example of SQL, because we are very close to autonomous database. So one of the things which you will find is that we would like to host our data wherever it is and run our model at the same place. This will give us immense speed, this will give us security, and this will also allow us to give more transaction with lower latency. This is the main purpose of running such kind of Oracle machine learning model on the SQL platform. In the autonomous database, what you have to do is you can actually go and build a decision tree, which can be a classification based model. Here in the vset list, you can see that we are trying to build an algo of decision tree, and we have given it a name of prediction of the affinity over the decision tree underscore dt, and this is a classification model where we have specified that we're going to pick the data from the mining data build, and then we are going to run this model. On the right hand side, what you see is that we are going to dynamically score this, and when you're dynamically scoring this, we are saying that okay, now you're going to run this my model, and you're going to find me the probability where there is a chance that a particular affinity is going to come through, and that probability is more than 50% or more than that, or 0.5%, and then you put it in a descending order. So in this very simple example, what you have seen is that you can run a SQL procedure, build a decision tree, and then use it to score that particular model where exactly your data is, and then get the result back and show that to the user. This gives you immense speed. But there are always chances that you will come up with a Python based model. And that also is possible where you can deploy an OML model which is built using Python, because there's a lot of data scientists who understand Python in a much better way. For that, you have to use OML for PY for scoring via SQL. The very first thing you will see is that our model, the way in which we are going to actually call this particular model and get the results is not changing at all. It is still select star from and giving the name of the model and giving you the probability of 0.5% over a probabilistic determination and a descending order. But here the difference is on the left hand side, where you are actually building a Python model. In the Python model, you are calling the similar commands as import pandas, import OML. OML is proprietary to us, and in that, what we are doing in the very first step is we are syncing that particular table. Once you have synced that particular table of mining data build, you are actually splitting it up just like normally you would do for any kind of model building. Once you have got the train X, train Y, you are going to call oml.rf. RF stands for random forest. In the random forest, we are saying that there is a max depth of 5 and there is going to be a 50 tree. In that, we are going to put a fit model. In the fitting, when you are trying to do the fitting of the model, you are going to take the train data and the test data and actually going to build up a model. So here you can see that we have built a model which has a prediction affinity for this particular random forest. This is the same model which we are probably going to use to actually get the results out. So you can see that in both the cases, once we have used the Python, another time we have used the SQL, but the model scoring has become much easier. This is using OML for PY, and previously it was for SQL. Now let's try to deploy a native Python model. Previously we saw what was there was inside the OML. So we used the oml.rf, but we can actually take it to the next step and call it via the REST API. So here what we are going to do is we are going to score, and using the scikit-learn and few other things, we are going to call this. So let's first build a linear model. And in that linear model, we are going to call the random classifier from sklearn. It's an ensemble model. And then we are going to build a random forest model predicting the species of that particular iris. Once you have built that particular model, you can save that model with the name rf_species, and then you can call that particular model at a later point of time by doing ds_rf_species to know what are the models I have stored. So you see, in the very simple step, we have been able to particularly put it in the service. Now, later on point of time, we are going to fetch that particular model using the ds.load my particular species, and then we are going to call the predict. And in this case, when you're doing the predict, you can see that the prediction result has come in, and it has both the predicted species as well as the species which has been there. So this will help us to understand that it is very, very easy to actually take that and create a particular thing. You can also take that and actually make a scoring logic out of it, a function call, and then put that function inside that particular ds.script. So I'm going to call oml.script.create and call that predict rf.species. This predict.rf species can be later on be made through the curl command, we can call it, and you can see that the script is here with a normal description. So now you can actually load that with the OML services. So you can say, okay, load my table, which is iris load, and then also load my particular function which we have made earlier, predict rf species, and it gives you the particular results. In this, it is going to show you the same results. You can also do the same thing with the help of a curl command. When you're using the curl command, you can also call it via the REST API. So you can say, I'm going to call the table apply and predict rf species, which is the function which we have made earlier. So it's a very easy way in which you can actually do all these particular steps of first building the model, storing that particular model, and then actually storing. After you've done the storing, you can actually score that by calling that function call and score that particular function call as a script. Now let's go ahead and look at how are we going to call this particular species outside of this thing. So in order to do that, you have to first deploy that particular model, because we haven't deployed that particular model. We have actually stored that particular model as an particular script over there, and that was the function call we were trying to do that. Now we can actually go to the next level, and we can actually we have to first make sure that we have the right tokens with us. In that particular token, we have to see whether the access token, without the access token, we will not be able to call that predict RF species, which is the previous OML script which we have made using that token. So this is the same curl command which I got earlier in that series. Now I'm putting it over here. Okay, run that, run it on my iris, and show me the results if the results is matching with what we have earlier. This is the result of the scoring in JSON format. I can visualize that data and see that data. It is giving me the same result over there, which is the same Satosa, same result, same vascular, and all of those results is what we are seeing over here. This is what we have generated with the help of the predict RF species, was the function which we have actually earlier stored in our database as a py script over there. This is what we have done to help us to actually use an OML for py to score a particular table. Now let's try to do the same AutoML. Using the AutoML, try to deploy that particular model. Now in this case, I can first of all, I have few experiments which I've done earlier. In this case, I want to find whether this guy will buy an insurance purchase or not. So I know that one of my model has done really well called the random forest. So let's create a notebook from that, and I will call it my prediction notebook. When I've done my prediction notebook, you can see that I've successfully been able to create that particular notebook. And now let's open that notebook. What's inside it? When you open that, you will find that automatically the notebook has been created with all the required things whichever we need. The first step is build the data. So it has got all the required columns over there. It has also got that this is my sync table. This is the query I'm going to run over there. And this is the full result you can look at. So this is bringing you all the original data used for that particular experiment earlier on. So you can see in a very easy way that you have been able to create a notebook. I can take out the train X and the train data to actually which we need to build this particular model. So I can see that X train, Y train, which is saying who's going to buy that insurance or not. I'm going to use the same random forest over here model, and when you're doing that random forest, you can say rf model.model.fit, and you can give your X train and the Y train data set. This is a classification based model, so the target is to buy a particular insurance. So you can see the algo name and few other hyperparameter tunings has already been done, and it has been able to tell how many trees are there, 12 or 14 or 18 for these particular attributes. Now help me find with this particular thing, will we be able to predict it or not? So let's, what do we have to do? We have to call rf model.predict. So here you can see I have done the rf.model predict, and it was able to give me the probability of each one of them for each of the customers. So you got the model predict output. We have been able to train. Now let's check the accuracy of the prediction on the original data set. Voila, I have got an 89% accuracy with just few steps which we have done without writing a single line of code, using the notebook which has done all the major hard work for you. This makes the life very much simpler for all our data scientists, for all our people who would find it very hard to write some of the codes, or they are not very well versed with that. So you can use the notebook to actually do all these particular steps of both deploying, using the prediction, and actually showing where is the accuracy of the model. So this notebook creation has helped. We also need to now go to the next level, which is basically you have been able to create that particular model. Do you have any way to deploy those model into the OML services using the AutoML UI? Yes, we do have it for you. Let's go and have a look at that. Okay, let's open the project. Let's open the AutoML. And let's go ahead and open the same insurance purchase prediction which we have earlier. Let's put a model which is doing good. I choose random forest in this case, which is doing good, and I deploy that particular model. I'm going to give it a certain name, alphanumeric name, and I'll say my insurance prediction. And I'm going to give a URI which is unique and insurance prediction model. Version 1, version 2, version 3, you can use anything, and you can have to click shared. If you do shared, anybody in the organization can be able to do that, take that model as a REST API and able to see that. So now there's another way to do the same thing. We did that through the AutoML, we did through the AutoML. Now we'll do it through the model. In the model, you see all the different models which I have tried or played around with. I can just select a particular model and hit the deploy button. Once you do the deploy button, you have to fill in certain details as what is the name of your model, what is the URI I'm going to reference it with in my REST API. So I'm going to call it affinity.predict. This is the version, this is the namespace, and I'm going to make it shared so that I can show you the demo later on as to how we can do this. Review all these current live deployments in a different screen, which is called the deployment screen, and you can say affinity card prediction and my insurance prediction model. Those are the two models which I have just shown you as to how to go about. Now you can see that the selected model has been deployed successfully over the box. Now we will head over and try to call these particular shared model for us. Let's do that. Here is the steps where we will be scoring the OML model using the thing. So I call the same San Jose box, and in that I've given affinity underscore insurance, which I have earlier made. And now the thing is that we call it the score. When you call the /score, it is actually going to hit the REST API, fetch the top 5 records, where it is going to find out what is the probability that this person is going to buy for me. And this is the classification model, so I'm going to take the probability. Okay, the probability seems labeled 0, 92%, chances are low or high. It is able to give you all those particular information from there for an affinity card prediction which has made earlier. I can visualize it through the Postman, and then you can see it over here that there's a probability that his year of residence, his Y game boxes, and all those helps us to understand that he's not going to probably buy or he's going to buy. That's the thing which we are going to do. So this model helps you to do that. Now let's try the next step, which is how can I do the same thing if I don't have an AutoML, or I want to do it with the PLSQL to deploy it to the OML service via REST. This is an interesting way of doing things because you have to take out those serialize an OML model with the help of PL/SQL. So we have to write a small function which is available, which is basically you can write a write serialized model. And what it does is that it will allow you to export an OML in database model to a serialized format, which you can later on put it on an object storage or any other place. But before you do that, make sure that you have all the database credential and the permission granted to you to do that. So here we have made this write serialized model, and that is the sum total of this stroproc which we have made, and it does the binary and does go loop over the while loop till you can get the thing. We're calling that as glm underscore mod underscore module. So I'm able to now, by using this command, I should be able to fetch out that particular model and put it into a serialized format, which I can put it in object storage or in the OML service, wherever we feel like we should be able to do it. Let's see that how we can do it. I'm going to export my serialized model to object cloud storage. That's the definition of over here which we are trying to attempt in this demo. The very first thing which we need to do is we have to call the object storage and do a pre-authenticated request, or called the parse. Once you do that, you can do that from the core infrastructure object storage, and we will need these pre-authenticated requests to store our serialized model, or else it will be a problem for us. So make sure you have the required credential pre-authentication for us to do that. We are going to use DBMS cloud package, which need to be configured with this proper cloud credential. So we're going to call this DBMS cloud dot create credential. Here you can see that I'm calling DBMS cloud dot create credential, and I'm giving my cloud cred, and I'm giving my username, password. This is my table, this is my data, and I'm going to build two OML models over here, one regression and one classification. In this, I'm calling glml model, which I have earlier made. So I'm going to do that. It's a linear model. So I created that particular PL/SQL procedure Then I'm going to call the another classification model, which is the class model, and I'm going to use select star from iris data to help us find the sepal. Based on sepal length, we will be able to find the details. So now we can do select star from this where owner is equal to OML user. Now you can see that both the models are present. We have to take both the models and export it out. We'll use the write model command to export out these things, but before that you have to make sure what is the autonomous data pump directory we are going to use for this. It's not a very hard, but it's a required step because you want to take it out with the help of that pump, that particular model outside from there, inside that. This is the same write serialized model we saw earlier. This is the classification, previous one was GL model. So now I got both these models, and I'm now going to send this serialized model to object cloud storage. Here we are calling this particular object storage of San Jose, and we are going to say put it in my bucket OML service underscore bucket test. When I do that, I'm going to do that for GLM model and the other one. Now this is the class model one. Now I've been able to take these two models and can be registered inside the REST to the OML service. Now these two mod file can be registered very easily to OML service, which we will see in the next step. So I have been able to fetch my particular model. Now let's see what is the model which we have fetched. We have two models, so we'll give that model, and in this case we are going to use the model OML insurance affinity. Okay, here is my model which I am going to use to store a serialized model into the OML service. The very first thing you have to do is call that particular model, and you have to say what is my model name, what is my model type, and then I'm going to say put it inside this particular location, and the data is at a certain location, and that creates the model ID for us. So that's step one for us, where you have been able to put it inside the model. Now the next step for us is that once you have been able to serialize the OML model and optimally give it a namespace and store it with a unique model ID, I have to deploy that particular model. To create a REST endpoint, this model deployment is an important step because you convert a model ID into a deployed model ID, deployed model solution, where you are going to deploy it. So now once you have given this particular model ID, take that model ID and create a deployment or the REST for you. Now I'm going to get this URL, and that is this particular URL, OML service, and I'm going to use that. And I'm going to use the next step of my IDs, my URI. What is the URI you want? You should remember that URI later on, because that's what you're going to use to get the scoring for that particular model. So that for that model ID at that particular deployment time, I was able to do it. Now next step for me is to actually predict this particular model. So I'm going to call that particular model. I'm going to call it with that same URI, affinity insurance, and I'm going to do the scoring of it. It's again going to try and help me to predict whether this person is going to buy or not, the same as the previous model. You can see now we are on the third step of the journey, which is after the deployment, which is the second, and this is the third. I was able to click on the send button, and this gives me the results. The result is same as previous, which says that whether it's going to buy or not going to buy, and it's given the probability of that particular thing results. So you can see in those three easy steps, without using AutoML, I can very easily call those three things: deploy, build the model, get a model ID, get the deploy, get the deployment IDs, and then model URI, use that model URI and score your particular model and get the predicted results. So this helps us to know that how can you actually go about in doing this particular thing of deployment and scoring, both with AutoML and using your own SQL mechanism of doing things. Now I can do the same thing for a third-party ONNX file. One of the ONNX file which normally will come into your pictures are TensorFlows. TensorFlows, you can actually convert them into ONNX and then use that ONNX model to build the OML service via REST API. Why don't we see a demo as to how we're going to do about that?
It's 18 hours.
So I'm going to use an OML service in this case. When you're using an OML service, the very first thing you have to do is, what is my model name I'm going to run? And what is, in this case, I'm going to run it with efficient netlight. And I've given all the details over here earlier on, which is one on, and it's an image file. And I'm going to try and predict a thing. So now I'm very much easily take that particular zip file and put it inside the model data and then call the hit button, which actually deploys that particular model and give me the model ID. So you have seen that Onyx model can also be loaded with the slash model step, and in the slash model you give the name of the model, you give the name of the model data, what is my zip type, what is my Onyx type, and then you go ahead and you deploy by clicking on the send, which gives you the model ID. Same place we have put it in the San Jose. So now let's try to see if I can create a REST endpoint. This is step 2 again as earlier, but now we are doing with the Onyx. So I got the model ID, I'm going to call that with the same model ID, hit that send button. Now I got the model URI, which is saying that ONX IMG model URI is the one which we are going to call to do the scoring later point of time. So let's try and see if we will be able to do that. Make sure that you have a valid token in all of these cases. Without the right token, you will not be able to do that. I'm not showing you that in the interest of time, but let's try to see if we can predict this tiger shark with the help of this. It's an image data. So I give that image data over there. I call the ONX IMG model URI. Yes, that's the one I'm going to call. Okay, I'm going to hit the send button. Let's see if it's able to predict the result out for you. Okay, it's able to predict the result for me. Let's see if it has been able to tell whether it's a tiger shark. Yes, it has been able to tell that this is a tiger shark for me. 99% accuracy is what it is doing that with. I can see that the same result in the classification for images also, and I get the results over here. So you can see that not only we took an ONX model, we got the model ID, we did the scoring, and now we got the results, whatever it is there for us. So what have we learned from all of this? We have learned that Oracle ML provides you with a lot of ways by which models can be deployed in a particular environment using OML, open source Python, ONX model. These are all the different ways in which you can get it done. You can also use the OML to actually get the same level of security as you will do it for an Oracle database and Oracle Cloud. Since the data and the REST APIs, they are all co-located at the same place with the highest level of security, you are going to get a very high amount of scalability, and you can do batching and you can do thousands of transactions per second, which is almost unbelievable power and latency which you can cut through and get the results which you can. And finally, you can see that a user can be a SQL based user, he can be a Python based user, or can be a normal Java developer who has been given a particular URI to hit and get the results from. These are some of the mechanisms by which you can do that. So in summary, models can be created using SQL, Python, and you can also do that with R. And once you have done that, you can be converted. Any model can be taken. You can take any classification and regression model, and you can use an ONX format also, and any third-party image classification can be converted to ONX image, as we see just now earlier, to get you that. What we also learned is that there are several ways to put your model into production. You can put it through SQL, you can export it out, serialize it out, you can put it in an object storage, call a Python script, and then put it inside the OML service. Then you can call using any kind of Python REST APIs or the Postman command. We saw that you can do a model ID, and then you can do the deploy and the score. So these are very easy mechanisms to do the same thing and get the model scoring done for you in a very, very short while. It was almost like a breeze that we were able to do that. So this is the power which you can harness with the help of our OML and all the services. Yes, I think so. I did answer the question around TensorFlow. So yes, we can do that with the TensorFlow. You can do it with classification. Yes, you can do it with regressions also. Yes, you can load billions of data over here. Okay. So you can, actually I can see some more questions. So you can try all of this OML for PY and all of these things, OML for SQL. We have built a lot of notebooks for you. We have given a lot of data sets to play with. We have built the Python, we have built it in R and the SQL for you, and you can try it out. And you can try all of these examples. I'm sure you will be not finding it very hard to start using it for your thing. It should be as easy as a cakewalk for you. With few steps, you can almost get and harness the power of machine learning very easily in your service. Thank you very much for taking part, and stay back for visiting all the other agendas and the sessions which we are going to have. Thank you so much for spending time with us today.